Yay, okay. So we went over 7 factorial before. That's just 7 times 6 times 5 going down by 1 all the way to what? When do we stop? When we hit 1. So what we're going to look at today is if we have n's instead. So instead of giving you what the actual number is for factorial, we're leaving it as an n. So our rule was with 7 factorials, we started at 7, we went down by 1. So we went 7, then 6, then 5, then 4. So if we start at n factorial, we're going to start at n and we're going to go down by 1. So n and then times 1 less, so n minus 1, then 1 less than that, so times n minus 2, then 1 less than that, so then times n minus 3, and so on and so forth. Okay? So dot, dot, dot. So instead of saying dot, 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 you could actually throw a factorial symbol in there at any point in time. So you could go n times n minus 1 times n minus 2 times n minus 3. And I could put a factorial symbol behind it, because all that means is keep going down by 1s till you hit 1. So at any point in time, you can put a factorial symbol instead of the dot, dot, dots. Now, once we know what the actual n value is, we could fill it in and stop once we hit 1, right? But if we don't know what the n value is, we have to actually fill in just n's until eternity for life. So example 1. Simplify the following expression. Leave the answer in product form. What's product? Statement. Yes, the answer to a multiplication statement. So we're going to leave the product not FOILed. So if there ends up being like a factor times a factor, or like a, I don't know, 2 term times 2 term or something like that, we're going to just leave it. We're not going to FOIL them together. For this example, that's not how it's going to stay. Okay, so leave the answer in product form where appropriate. So what we need to do first is we need to decide, is the numerator bigger or is the denominator, the bottom, bigger? So we have n plus 2 factorial over n factorial. If you don't know which one is actually bigger, put a number in for n, and which number results in bigger is the bigger one. So let's pick a 3. So on the top, we get 3 plus 2, which is 5 factorial, over 3 factorial. So which one's bigger? The top. So we're going to expand the top until we get the bottom. Okay? So in this case, so this equals, if the original question does not have an equal sign in it, it is not an equation, it's an expression. So in this case, this doesn't have an equal sign in it, does it? No, so it's an expression. So we're going to take this, and we're going to run equal signs down the left-hand side whenever it's an expression. When it's an equation, wherever the equal sign exists, you just keep rewriting it, right? But when there's an expression, you better have left-hand equal signs, because what you're saying is this expression equals the next one. And they all equal the same thing, they're just written in different ways. Okay? They will dock you if you don't have your equal signs and stuff like that. And that's the biggest pet peeve of profs. Profs complain in university that you guys don't have equal signs, or you don't know where to use them, and you use arrows or random things that aren't equal signs. Arrows come up a lot. Okay, so we are going to expand the top. So we start off with n plus 2, because it's bigger on the top. What's 1 less than n plus 2? N plus 1. What's 1 less than that? N plus 0, or just n. And then I'm going to put a factorial symbol behind it. I could keep going. I could go n minus 1, n minus 2, n minus 3, n minus 4. But why did I stop? Because it matches that denominator, right? Matches the bottom. So now I'm going to write my denominator, n factorial. And now this cancels. And you know that whenever you cancel, what's left behind is a 1, right? Whenever you cross stuff off, you're left behind with a 1. Not a 0, because if you were left behind with a 0, it would cancel the whole top. It would cancel the whole numerator. So this and this cancel, so you're left with 1s, correct? So now you technically have n plus 2 times n plus 1 times 1, which does nothing. But if it was a 0, the whole thing would be gone, right? So whenever you cancel, it's actually a 1. So on the top, we're left with n plus 2 times n plus 1. And in the denominator, I have a 1. We agree? Do I have to write a 1 if it's in the denominator? No. Why? Because if I have 4 pieces of pizza, or I have 4/1 pieces of pizza, I still have 4 pieces of pizza, correct? If I have a quarter, or 1/4 pieces of pizza, can I cross that 1 off and say it equals 4? You're like, no, that's ridiculous. That person's stupid. So when you do this later and you cross that 1 off and get rid of the whole numerator, remember this moment when you're like, that person is so dumb, because that would be you later on. We want that to be you, okay? So if you're left with just a 1, if everything cancels off on the top, are you actually left with nothing on the top? No, every time you cancel, you're left with 1s, and 1 times 1 times 1 would be 1s. So when you have a quarter, or you have 1/n plus 1, you're still left with 1/n plus 1. It can't become just n plus 1, right? Just like a quarter cannot become 4. Does that make sense? You can make pizza way better too. You get 4 pieces instead of a quarter. Okay. B, which one's bigger? The numerator, the top, or the denominator, the bottom? Why? Right. On the top, there's actually 1 more taken away than the bottom. If you don't remember, you can put in like a 5. 5 minus 2 is 3. 5 minus 1 is 4. 4 is bigger than 3. Therefore, the bottom is bigger than the top. Right? You can just plug a number in for n to check it out. So we're going to expand the bigger one. We're going to expand the bottom. So the top is going to stay the same. We have an expression. It's going to equal the next expression that we change. So we're going to have n minus 2 factorial on the top. On the bottom, we have n minus 1 factorial. So we're going to go n minus 1. What's 1 less than that? N minus 2. You will catch yourself going up. With the negatives, you will move up. Lots of people do it. It's just habit. So now they match. This 1 cancels off this one. And what am I left with? Equal to 1/n minus 1. Because these are expressions. Expressions means that the original question does not have an equal sign in it. So it's an expression. If you have an expression, you have to say this equals the next one equals the next one. So you have left-hand equal signs. Okay? Try C. Okay, on the top we have n factorial. On the bottom we have no factorial. So the only thing we can expand in this place is the n factorial. And so I'm going to expand it to n minus 1. Now I'm going to show you, don't write this. Some people stopped here and they said, okay, I can cross these off, and then you just have a random, like, so if you stopped here, there's still a factorial symbol there, technically, correct? So n and n can cancel, that's true. But is n minus 1 the same thing as n minus 1 factorial? No, n minus 1 factorial means n minus 1 timesing by 1 less all the way down to 1, right? So I can't stop here because I can't cross an n minus 1 factorial off. Another thing to realize is if all you're left with is an exclamation mark, it's just sitting there. It doesn't have anything. It can't be a factorial symbol because it doesn't have a number in front of it. Like a factorial symbol, in order for it to be a factorial symbol, has to have a number in front of it, and then it tells you start, or a letter, that you start there and you go down by 1s, right? If you just have an exclamation point left, then you have an exclamation point and you're in English and not in math, and that's a problem. Okay? So we can't stop here. I can't cross these off and have an exclamation point. I can't pretend to ignore the factorial symbol and cross them off. So I actually have to not write the factorial symbol and go one more, n minus 2, and then write the factorial symbol. Now these cancel, and I'm left with n minus 2 factorial. Okay. This one says algebraically solve. So in the end, I'm going to need n equals something with math involved, right? That's what algebraically means. And solve means tell me what the variable equals. Algebraically means do math at the end without your calculator. Okay, so we have n fact. Now this is what you guys all do. You guys start writing right below this. And then you say you ran out of room, but never use this because you just used my question as the start of your work. Don't do that. Rewrite the question to the left and like use space, okay? So we do n factorial over n minus 2 factorial equals 42. What was the first thing I told you to do when you have something like this? Ignoring the equals 42, because you've seen this other side, the left-hand side. You want to expand it, and you want to simplify it. So you want to expand it and then cancel. Which do we expand? The greater one. Which one's bigger, n or n minus 2? N. Why? Right. The other one is taken away from n, so n is bigger. We can also check with a number. 5 factorial, 5 minus 2 is 3 factorial. So that one's bigger, so I expand that one. Look, this one has an equal sign. So when it has an equal sign, do I randomly put another equal sign on the left and carry it down? Sure, like, no, that's silly. You all do it. Stop it. Yeah. So we're gonna erase that bad boy. If it has an equal sign in it, and the equal sign exists, leave it exist where it is. Don't add more. It doesn't want more. It's not real. It's actually not real math. So just let the equal sign exist and carry that baby down, okay? If it doesn't have an equal sign, it goes on the left and carries its way down. Yeah? Expression, equation, very different. Okay, so we have an equal sign. We're going to leave it. We're going to leave it be. Thank you, equal sign. And then we're going to expand the top. So we have n minus 1, n minus 2 factorial. Why am I stopping here and putting a factorial? Because it matches the bottom. And then I have an n minus 2 factorial on the bottom equals 42. Now what can I do? I love smartboards because I can change marker colors. Then you can see what happened. Yeah. And I'm back to grade 11. Woohoo! To be honest, your guys' grade 12 skills are usually really great. It's your grade 11 skills that are a little subpar sometimes. So it's like, we're here, and then we hit grade 11, they're like, oh, I don't know how to do that. And like all this convoluted grade 12 stuff you got, and then grade 11, it's like, well. Even grade 10. Grade 10 sometimes is dicey. Okay. Like reducing a radical. Okay. The front stuff here is grade 12. We agree? Boom, we hit grade 11 now. What would we do if we were in grade 11, ignoring all this front stuff, and we had n minus 1? Yeah? Yes, put the n into the n minus 1. So we're going to go n into n squared, and then n times negative 1 is negative n equals 42. And what did I tell you? We just did this. You have to move everything to one side and equal to 0. I always like the squared being positive. If the squared is negative, you have to do decomp. So if you have a positive 1, you can go right to brackets, correct? If you have a negative 1, you have to do decomp. You have to replace the middle 2 and da-da-da. So instead of making yourself have a negative 1, move that bad boy to the other side, make a positive 1, and no decomp, right? Yes. Okay. So we're going to move that 42 over. And then we go, what times what equals the first times the last, so 1 times negative 42, so negative 42. And what plus what equals the middle, negative 1. Yes. Multiplies to give you the outside, adds to give you the inside. It's grade 10. Boom, boom. It's kind of like a heart, but joining back in the upside down heart, really. It's 7. This is really hard because your multiplication facts are a little subpar too. So it's going to be, it's just the 7 and 8 that kills people. 7 times 6. Which one has to be negative?
7.
Why?
Because it has to add to negative.
Has to add to negative 1. So whatever it has to add to, if this is the thing, if it has to add to a negative, the bigger one's negative. If it has to add to a positive, the bigger one's positive, right? Because I need to have a negative number ultimately, so my bigger number needs to be negative. Then I can go right to brackets. N minus 7, n plus 6 equals 0, only because there's a plus 1 in front. If it had a minus 1 in front, I would have to do decomp or move everything to the other side, set equals to 0, and go to brackets. Okay? Not done, because it says solve. It doesn't say, get me, this is grade 10 with an equals 0. Okay, so we're going to go n minus 7 equals 0, n plus 6 equals 0, n equals 7, n equals -6. Now, the great thing about solving in all of mathematics is you can check it. Every single time I ask you to solve, you can plug back into the original, and left side should equal right side. If it does not, you screwed up in either your check or in your question, okay? Whenever you solve, you should be able to walk away from the question knowing you got it right or not, because you can check it. So I'm going to try 7. 7 factorial over 7 minus 2 factorial equals 42. So that's actually 7 factorial over 5 factorial equals 42. Now, let's think about it this way. Just like we expanded those other ones, you can expand the bigger one here. So we get 7 times 6 times 5 factorial. I don't need my calculator. 5 factorial equals 42. These cancel, and I get 42 equals 42. So that's good. Yay. Woohoo. That one's awesome. -6. -6 factorial is not even possible. You can't do it. You have to stop at 1. So we put a not equal to sign and extraneous. If you don't say it's extraneous and you only box the other one, you haven't told them anything about it being extraneous, and they'll think it's an answer, and you lose marks. So, once again, over here is our formula sheet. In the corner here, it says perms, coms, and binom. This little corner is your perms, coms, and binom. That's going to be on this unit test. You'll be getting a laminated formula sheet. This is the Npr formula. It's the permutation formula. So it goes like this. Npr equals n factorial over n minus r factorial, which looks quite similar, this n factorial, n minus r factorial. It looks very similar to what we were just doing, doesn't it? Okay. We're starting with permutations tomorrow, too. We've been doing perms and coms, kind of, but you just didn't know it. Permutations, order matters. Okay? So if you're arranging books on a shelf, the moment you hear arranging, you're putting them in a specific order. Therefore, it's a permutation. Okay? So one of the questions we did previous to this is we arranged 6 books on a shelf, did we not? Yeah? So we had 1, 2, 3, 4, 5, 6. So we had 6 books, and we chose all 6 to arrange them, right? So we had 6 in this blank, and we put down a book. Then we had 5 options for this blank. We put down a book, 4 options for this one, because now we only have 4 books left. Leave a book. 3, leave a book. 2, leave a book. 1. Now, these are all going down by 1, correct? So I could have said 6 factorial, or I could have said 720. We agree? Okay. The other thing we can use is the permutation formula, or the button on our calculator. It only works when we have no repetition. So there's no books we're repeating here, correct? We had no repetition. Once we put a book down, we couldn't reuse it, right? So you can only use this formula when it is something that has to be in order matters, and you can't repeat. So if, for example, you had an unlimited amount of books, right, of each of the 6 books, then you could have 6, 6, 6, 6, 6, 6 in each of the spots. If you had an unlimited amount, right, then you couldn't use this formula. So what we do is we use the Npr formula. We're arranging books, so it's a permutation because we use the word arranging. Order matters. N represents the total. R represents how many you're choosing. Therefore, N is always greater than or equal to R. Because if you have 6 books, at maximum, R could be 6, right? Or less. You could have 6 books and arrange 3 of them. You could have 6 books and arrange 4 of them. But you can't have like 6 books and arrange 8 books. That makes no sense. Okay? So N is greater than or equal to R. So in this case, for this example up here, we have 6, 5, 4, 3, 2, 1 multiplied, or 6 factorial. Or we could have said, hey, I have 6 books, and I'm going to arrange 6 of them. So how do you do this? You press the 6 button. Then you go to where factorial was found. Math. Arrow over to probability. And then you're going to pick number 2, which is NPR. And then you're going to put 6 in again. Because 6 math, so this gets put in for the N and that gets put in for the R. And you should get 720. So if this was a written response of how you arrange 6 books on a shelf, and you gave me 6 times 5 times 4 times 3 times 2 times 1, or you gave me 6 factorial, or you gave me 6p6, none of them is better than the other one. They'd have to accept them all. So this is just typing in 6p6. So say I had 6 books and I arranged 3 on a shelf. Well, now I would have 3 spots on the shelf, correct? And I would have 6 books for this blank, 5 books for this blank, and 4 for this one, correct? And that's 120. Or if I use the permutation formula, because I'm not repeating the books, I could say I have 6 books, permutation because I'm arranging them order matters. And how many did I pick? 3. I arranged 3 of the 6 books. So you can try that out, 6p3, see if you can get it. We're doing more of this kind of something tomorrow, but I just wanted to show you why we're learning the factorials. So this would be, I have 3 spots to put books, and I have 6 books to put in the 3 spots. So I have 6 total, but I'm only arranging 3 of them. So I have 6 options for this one, put 1 down, and I have 5 in my hand, put 1 of those down. I have 4 in my hand, put 1 of those. Yeah. You can use it anytime you start at a number and go down by 1 to another number. So even if you had a restriction, let's say you had this, 2, say you had this. In the first, I'm arranging 7 books, let's say, okay, in 4 spots. And the first blank has to have the 2 books that are history books. Then I would put a 2 here, and then I'd be left with 6 books, 5, 4. So technically, if you wanted to use that button, you could go 2 times 6p3. Because I started at 6, I went down by 1 3 times. And it would get you the same answer. Does that make sense? Because it locks it to that letter when you press the NPR. Okay, then we're going to flip over. So why do we need to use this formula if we can just use our calculator? Well, that's kibosh now because there's written response on your diploma. Before that, they found ways, so they'd do something like this that you can't punch it into your calculator. They'd make it where it'd be an N and an N, so you actually have to show some work too. Okay? Or they would stop you. They'd say, James did this question, find the error. And they wouldn't get down to the very end. So you don't have as many error questions because you've written response now. Okay? Because they had to write them in a way that you couldn't just go 6p2, 6p3, 6p4 until you got the answer. So in order to solve this one, we're going to use the formula. We have n minus 1 p2. The formula, whenever you see this, you can plug it into the NPR formula, which is on your formula sheet, so you don't have to memorize it. N factorial over n minus r factorial. So we have n minus 1 p2. So this is just goes in the place of wherever we have n's in the formula. And this goes in the place wherever we have r's in the formula. So every time we have an n in the formula, so here and here, we're going to put in n minus 1. And where we have an r, we're going to put in 2. So we're, instead of putting an n, we're now going to put in n minus 1 factorial over n minus 1 minus 2. Factorial. So that's just this, putting this into this NPR formula, right? I literally just put this in for the n's, this in for the r's, and it equals 90, so I have to go equals 90. This is 2 is r, so I just put in 2. So then we can simplify the left side. N minus 1 factorial over n minus 3 factorial equals 90. And then we're back to where we were before. Simplify the left-hand side, which is the smaller one. I literally just went n minus 1 minus 2. I just collected like terms, guys, which is minus 3. Which one's bigger, n minus 1 or n minus 3? N minus 1. Try it out. Okay, so we're going to go, n minus 1 is the smaller one. So we're going to do n minus, or the big one, sorry, n minus 1, n minus 2, n minus 3 factorial. Stop there so it matches the bottom. Cross off the n minus 3, and then I FOIL. So I'm going to get n squared minus 2n minus 1n plus 2 equals 90. And then I have a quadratic because I have n squared, so I need to move everything to the left. So I'm going to get n squared minus 3n minus 88 equals 0. And then it is what times what equals negative 88. What plus what equals negative 3. So it's negative 11 and 8. So I get n minus 11, n plus 8. N minus 11 equals 0. N plus 8 equals 0. N equals 11. N equals negative 8. That can't happen. This one is extraneous. I'm going to run out of room. Because you can't do a factorial of a negative number. So if I go back to check it, and this number has to be, like I'm choosing from this number, right? So if I put in negative 8 back here, it's going to be negative 8 minus 1, which is negative 9. So that's saying I have negative 9 things, and I'm picking 2 of them. Like this would be negative 9 P2. There's no way you can have negative 9 shh, guys, quiet. Can't have negative 9 objects and pick 2. Yeah. So here is your homework. You rarely get homework time. There it is. So this one and this one, you're going to have to fill into a formula. This is going to be your n. This is going to be your r of that NPR formula. This is going to be your n. This is going to be your r. This is going to be your n. This is going to be your r. So you have to fill into the formula twice. So try them out. When you get stuck, ask. The answers are down here.